Hey guys, today we are going to talk about properties of line segments. So to start off, we need to talk about the correct notation so we can write about our lines and segments correctly. So in this first box, I've got line AB. It extends infinitely in both directions, and I've got points A and B on it. So I'm going to name it with capital A, capital B, with a line with arrows across the top. In the second box, I've got segment AB. I'm going to name it by using its endpoints, capital A, capital B. But this time I've just got a line across the top with no arrows. That is talking about the segment. In the third box, I've got segment AB with a length of 5. So if we want to talk about how long a segment is, we're going to name the segment with the capital A and B, but to talk about its length, we don't use a line over the top. And so I'm going to write AB equals 5 to show that its length is 5. Now, we can talk about points being between other points. So here, I'm going to have point X be between points A and B, and I'm going to draw that right on there. Now, what that means is, first, A, B, and X, those points all have to be collinear, which, if you remember, that means they are on the same line. Now, the second thing that tells me is that the length of the first segment, AX, which is this one right here, plus the length of the second segment, XB, which is this one right here, that is going to equal the length of the entire segment, our segment AB, which is this whole thing from A to B. Alright, now let's try an example to see how this really works. So this one says point R is between points H and D. So before I do anything, I'm going to draw a picture because that is going to help tell me what is really going on. So here I've got my segment HD, and I've got point R somewhere between them. Now, they tell me that segment HR is 13, and the length of DR, or RD, is 18. And they want me to find the length of the whole thing, HD. So we're just going to do exactly what we just saw and just learned a minute ago. So we know that the length of that first segment, HR, added to the length of that second segment, the length of RD, is going to give us the length of the whole thing, the length of HD. So I'm just going to substitute in what they gave me, what we're told. And so HR is 13, and RD is 18. And once I add those together, 13 plus 18 gives me 31, and that tells me that HD, that whole segment, has a length of 31. You can kind of think of this like a road trip. It's a short road trip in this case, but let's say you start at home, point H, and you drive for 13 miles, and then you stop at a rest stop, point R. And then after your rest stop, you keep driving another 18 miles to your destination, point D. Now, how far did you go in total? What was the whole trip? That was just add together the two parts, 13 plus 18, and that gives you 31 miles for this road trip. Alright, now this next example gets a little more tricky. So I've got point A between points B and C. Again, I'm just going to go right ahead and draw a picture. So I've got point B and point C and point A somewhere in between them. Now, what they tell me is AB is 3x. And the next thing they say is BC is 7x minus 2. And that is that whole segment. BC is 7x minus 2. And then AC is 2x plus 8. So it looks a little more complicated, but we're actually just going to do the same thing as we just did in that first example. We know that that first segment, BA, or AB, plus the length of that second segment, AC, is going to equal the length of the whole thing, segment BC, that length. So then I'm just going to substitute in what they tell us in the problem. BA is 3x, and then AC is 2x plus 8, and that is going to equal BC, which is 7x minus 2. And from here, it's just algebra. We're going to combine like terms on that left side. 3x plus 2x gives us 5x. And then we've got that 7x minus 2 on the right side still. And now I'm going to subtract 5x from both sides to combine our x's all on one side. And I get 8 equals 2x minus 2. I'm going to add 2 to both sides then. And I get 10 equals 2x. And the last step, just divide by 2. And so I get 5 equals x. And that is our answer to the first part of the problem. The next thing they ask is to find AC. Well, they told us at the beginning that AC equals 2x plus 8. And now that I know what x is, again, it's just algebra. I'm going to substitute 5 in for x and then just solve from there. 2 times 5 is 10, and then we're going to have plus 8. So that tells us that AC equals 18. And that's it.